Okay, so chemistry practice final, part 1. Number 1, you need the word science, you need the word composition, you need the word changes, and then you need to have other words that make a thought. But my full thought is science of the composition of substances and the changes they undergo. Bonus point somewhere here at the top. If you mention that organic carbon or organic chemistry has to do with carbon, I would give you a bonus point. And I would also give you a warning if you're in college and someone says, you should take organic chemistry. You should ask, do I have to because of my major? And if they say yes, you should just sigh and go take your beating. If they say no, take another class. You do not want that. I was friends with enough chemistry and science people at Penn State to know that the only times I heard references to organic chemistry, or OChem as they said, the voice always contained a great deal of either fear, sadness, or more likely both. Organic chemistry was not enjoyed by the general population in my college days. But organic chemistry means carbon. I don't recommend that class. 2 to 7, I'm not claiming I cornered the market on scientific method, what it means, because every book does this a little bit differently. But the way this book did it, step 1 was experiment. Step 2 is hypothesis. Step 3 is more experiments. Step 4 is a scientific law, but it's a 6-point question, so we'll need to double back. But experiment, hypothesis, more experiments, scientific law. Experiments I had a little bit of a follow-up on of collect facts, which I'm thinking ideas there, and data, I'm thinking math items, numbers, by observing. So we collect some facts and data by observing. That's what the experiment phase is about. Hypothesis, I just wrote theory. It's like what you start off thinking and you hope it works out. More experiments may clarify that, and if it keeps working and working and working, it becomes a scientific law. 8, I'm going to say turn other stuff into gold. That was important to chemistry because that drove the beginning of chemistry to some degree. People were thinking if we could turn aluminum, which is common, into gold, boy, we'd all be rich. But it doesn't generally work out so well. The only things I believe you can turn into gold are things that cost more than gold. So that's not a winning operation. But turning other elements into gold. 9 is Lavoisier. I will make you spell his name right since he's the father of chemistry. That seems like a homage to him. Lavoisier. 10 is Nobel, Nobel prize. If you put Noble, that's not right. 11 was Europe for the first part of science. Since then, number 12 is USA. 12 is a gravitational force between an object and a planet. So you'll need to mention gravity and a planet there. You could say Earth specifically if you want, but it's a gravitational force between an object and a planet. 14 is the quantity or the amount of matter. 15 is anything with mass and volume. If you want the shortest answer, put little m for mass and big V for volume to abbreviate. I think the book might have said anything that has mass and takes up space, but taking up space means it has volume. So if you want to shorten that or leave it, I don't care. You don't have to word for word me, but you have to capture all the important ideas. So that one, mass and volume, are the 2 important ideas, one way or another. 16, it's the same everywhere. 17 is the space an object takes up. 18, I'd probably rather have the V equals, but could live without it. But you definitely need length times width times height. LWH is what I put. 19, I could live without the D equals for density, but I definitely want to see mass over volume. I just put M over V. 20 was the English system. That's what we have with ounces and stuff. SI is what the rest of the world uses. 22, it's good because of powers of 10 and because it gets used everywhere except here. 24, I would just line the answer up with the word underneath, and then you don't have to worry about putting the wrong thing in the right spot. But gases is G over L. Volume is a big capital L for liters. Length is a little m for meters. Density for solids, liquids is G on top of ml, grams per milliliter. Mass is grams. 29, 3 points for Celsius versus Fahrenheit versus Kelvin. So 1, 2, 3, Celsius, Fahrenheit, Kelvin. Celsius, you should mention water is a key thing for deciding these temperatures. For Celsius, 0 is freezing for water, 100 is boiling for water. Not everything freezes at 0, not everything boils at 100. Water does, that's how they pick those numbers. Fahrenheit, again, also mentioned water. 32 is freeze, 212 is boil for water. Kelvin, say absolute 0 is the foundation, which is 0 Kelvin, which is negative 273 degrees Celsius. And I don't know that I'd mark it wrong over this, but it's worth a note. Celsius uses the degree sign, Kelvin does not. But mention absolute 0 and mention both of those numbers. That's what we're hunting for our temperatures. 35 is anything other than 0. Zeros that have bars on top of them. Zeros that are between other sig figs. Don't say zeros between other numbers, because then it makes it sound like this isn't significant, but it is. When a 0 is between other sig figs, it doesn't matter if those are zeros or not zeros. And then the last one is zeros at the right end of a decimal number, which is stuff like this. This 0 is at the right end of a decimal number. That's our fourth category. 3940, at some point you adopted the rules of just always round last, because when you do this the real way, sometimes you're supposed to round first, sometimes you're supposed to round last, but that was going to be a year-long hassle, so that got abandoned. And then the other thing is that it's based on the fewest sig figs in a number in the problem. It's based on the fewest sig figs of a number in the problem. No, I'm sorry, those are the real rules. At some point you abandoned these rules, but those were the real rules. For multiply and divide, you're always supposed to round last, and you're supposed to do it based on the fewest sig figs that are in a number in the problem. Let's do repeats at the end. If you have a repeat, just jot which one, but I'm just going to plow through, because if people are watching the video later, they don't care about our repeats maybe. 41 is the opposite of 3940. If we're adding, subtracting, you round first, and it was based on the place. 43 is to write really big and really small numbers in a convenient way. 44 is F equals 1.8C plus 32. 45 is a fraction, C equals F minus 32 on top, 1.8 on the bottom. 46 is C equals K minus 273. 47 is K equals C plus 273. I don't know that I did switch the order on the test, but I would guess that I would, just to make sure you know the items and haven't just like gone parrot mode and are ready to rewind this and play it like a record. And that used to be a dated reference, but records are back. Vinyl is in. 48, in no particular order, there's giga is a capital G, that's a billion. I would write 10 to the 9th, it's easier. Mega is a capital M, million, 10 to the 6. Kilo is a K, that's a 10 to the 3. Hecto is an H, that's a 10 squared or 100. Deca is DA or DK, and that's a 10. Deca could also be DECA or DEKA, I don't care. Kilo has one L. Deci, DECI is a little d, that's 1/10. Centa, CENTI, little c, that's 100th, or 10 to the negative 2. Milli, M-I-L-L-I, that's a little m, that's 10 to the negative 3 for 1,000th. Micro, M-I-C-R-O, we have to go Greek M, which looks like a cursive U. Just make yourself a cursive U and then tell yourself it's an M. It is. That's 1,000,000th, or 10 to the negative 6. And then nano, N-A-N-O, is an N, that's a 10 to the negative 9, or 1,000,000th. Make sure the G and the mega are capital, the others are all lowercase letters. 78 is states. Give you a bonus point if you drop in the fourth state of plasma is another state that you don't really deal with, because that's like inside of stars, and I don't think you've been there. 79 is not the same throughout. 80 is the same throughout. So like air is homogeneous, Something like your chair, which is made up of all different things, is not. 81 is a pure substance that can't be broken down. Elements are just what they are. They can't turn into other components. A compound is a pure substance that can be broken down, like CO2 can be broken down to C and O. C and O can't be broken down. Not appearing on this test, but elements are what's on the periodic table. Bonus point, at the time of the writing of this book, there were 111 elements and 90 were natural. So if you tell me there's 111 elements and 90 are natural, I'll take that. But I'm sure the 111 is a higher number by now, because things change. Molecule, atom, 83, 84, both start off about smallest piece. A molecule is the smallest piece of an element that can undergo chemical, molecule is smallest piece of a compound that can undergo chemical change. Smallest piece of a compound that can undergo chemical change. Atom is what I started to do a second ago but was wrong. Atom's the smallest piece of an element that can exist and she'll still show the properties of that element. 85 is molecule because molecules are made of atoms. Just saying molecule will do it. And then for trivia, if you tell me for another bonus point, 254 million atoms, according to the book, would fit into an inch. Just to give you some sense of scale, you take an inch, we could fit 254 million atoms into that space. 86, physical, you can observe it without changing composition. That's enough words for me. You could also say chemical, you can only observe it if it changes composition, or you could only observe it if a new substance was formed, something like that, that would work. Like if we are cutting something, is that involving physical or chemical activities?
Physical.
That is physical, because it's still the same stuff. If you burn something up, that's chemical, because you got a new thing. Something rusts. Chemical, that's a new thing. You get the idea. Bake a cake, that's chemical. It's not the same thing anymore. 87, the difference between the changes and the properties. The changes were a process, the properties were facts. So if I say like, I can burn this, that's a, which makes it a property. If I actually went and grabbed a match and burned it up, that's now a
Process, change.
That's a change. So the change was like a verb, an action. The property was just a fact. So change is process, property is fact. I would take action too. If you said change is action, property is fact, that works. Again, you don't have to word for word me, you just have to get the idea. 88 is the capacity or the ability or some other word like capacity or ability to do work or to transfer heat. And when I say or, I don't mean pick one, I'd like both of those. It's the ability to do work or the ability to transfer heat. Energy can be thought of either way. Heat energy is energy transferred from high temperature to low temperature. Kinetic energy is energy of motion. Again, if you have repeats, just jot down a little side note of which number you need to repeat, and I'll loop back for repeats. 91 is the energy of position or state. 92 is joules and calories. Doesn't matter which goes where, just have those two things. Specific heat is the heat it takes to raise 1 kilogram by, is a small but important word, 1 Kelvin. Don't say 2. If you are changing things to a temperature of 1 Kelvin, you're making everything really, really cold. That's not where we live. So we're experiencing some technical difficulties, but if we missed it, 94 was the heat to raise 1 kilogram by 1 Kelvin. Instead of 1 Kelvin, you could also put 1 degree Celsius if you'd rather have that. 95 is delta Q equals MC delta T, and when I say delta, you're going to write a triangle. 97 is mass, can't be created or destroyed. 97 is energy, can't be created or destroyed, but add on the disclaimer, but it can change forms. Energy can't be created or destroyed, but it can change forms. Side extra credit in this area, if you write down 3 things. Einstein has a law that linked those, so write Einstein. E equals mc squared is the famous equation for that. And then the name of that is the law of conservation of mass hyphen energy. So law of conservation of mass energy, Einstein, E equals mc squared. You can turn mass and matter into energy or vice versa, that's true. 98 is on the right, 99 is on the left. 100 you have to say other than aluminum, which is a metal, but you don't have to say that it's a metal, but you do need to mention aluminum. Metalloids are, other than aluminum, anything that touches the step line. So on the periodic table there's this heavy step line. Anything that touches the step line is a metalloid, but not aluminum. Aluminum's a metal. Formula, let's see, these, I 100% mix these up, but I don't cross from one zone to another. So like uranium is on here to be a U, but it'll still be in that direction. And like the stuff that's at the bottom is still on the bottom. I didn't cross anything from top to bottom or vice versa. I kept them in the direction these were, and I didn't trade out any elements for any other elements. It's these same 22. So we're gonna go big U, then big C, little r. First letter is always capital, so I'll quit saying that. Every other letter is small, so I'll quit saying that. But carbon is C, then we have Mn, then we have He, B, Au, CO, Ne, Ar, PT is a little bit of a weird one, and then Bi. When we go the other direction, it's silicon, not silicone. Element is silicon, S-I-L-I-C-O-N. Silicone is breast implant. Ni, nickel, is N-I-C-K-E-L. If you put that as an L-E, you made up a word that isn't a word. Selenium, S-E-L-E-N-I-U-M. Arsenic, A-R-S-E-N-I-C. Antimony, A-N-T-I-M-O-N-Y, not to be confused with alimony, which is divorce. Radium, R-A-D-I-U-M. Krypton, which is not kryptonite, K-R-Y-P-T-O-N. Beryllium is a tough spell, B-E-R-Y-L-L-I-U-M. Titanium, T-I-T-A-N-I-U-M. Xenon, X-E-N-O-N. All of the goofy ones I said are real answers I have seen with my own eyes on tests. The leader of the group is probably silicone, followed by kryptonite, followed by alimony, in that order I would say. But I've seen a fair amount of kryptonite, but I think I've seen silicone more times on the test than I've seen kryptonite on the test, but they both happen. 123 is AMUs. 124 is carbon-12. I'd like to specifically say carbon-12 because there's different kinds of carbon. There's carbon-14, there's other stuff in the world, but carbon-12 is my best answer. 125 is 12 AMUs. 126 is Dalton, D-A-L-T-O-N. Again, do repeats in a minute. 127 is Rutherford, R-U-T-H-E-R-F-O-R-D, but I won't mark him wrong over spelling. 128, I just drew you a nucleus, so you should label that as a nucleus to get a point for drawing things. Who lives inside? Protons live inside. Neutrons live inside. And floating around the outer world is the electrons. So there's a drawing for some of that. Then, let's see, listing them, I'd want you to spell them all out somewhere once. So protons, spell it out. Neutrons, spell it out. Electrons, spell it out. For abbreviations, I'd rather you not just do P, but go P plus, the E's, E minus, the N's, little zero. In terms of charges, the protons are positive 1 charge, the electrons are negative 1 charge, and the neutrons are neutral. I'll tell you a bad physics joke if we have time in a minute, if you haven't heard a bad chemistry physics joke later. Proton mass is 1 AMU. Neutron is 1 AMU. Electron, the best word is negligible. Can anybody explain what negligible means?
Like, doesn't really matter. Insignificant.
It's really close to
Nothing.
nothing, but it isn't. It's something. There is some tiny like bit of mass. It's so tiny it doesn't really matter, but it's there. So don't say 0, because 0 isn't quite it. Negligible is a better word, meaning really close to 0, but not. And I'll spare you a calculus lesson on limits until someday you get to calculus, but that's what it would take to explain the word negligible, I think. 144 is electrons. Electrons make all the magic happen. 145 is the number of protons, counting the protons, something just about the protons with another word in your answer. 146 is the protons plus the neutrons. If you have a proton count plus a neutron count, that's what gives you the mass number. An ion is when an atom gains or loses an electron. Later in the year you learned that things that have 1 electron would like to...
What did you say?
Something with 1 electron wants to give it away. Something with 7 electrons wants to gain 1, because they like to have 0s and 8s. 148 is having the same atomic number and different mass numbers. So same atomic number, different mass numbers. An example of that would be a minute ago I talked about carbon-12 and carbon-14. What causes that discrepancy for 149 is that the neutron counts are different. 150 is because you have to do some averages. So like carbon-12 has a mass of 12. Carbon-14 has a mass of 14. But if you have some of each, the true mass of carbon is going to be somewhere between 12 and 14, because you have to like average that stuff out based on its frequency. 151 is 7. 158, you could either memorize a bunch of numbers, or you could memorize the formula 2 times stuff squared, and do 2 times 1 squared, 2 times 2 squared, 2 times 3 squared, 2 times up to 2 times 7 squared. But the counts on these will go 2, 8, 18, 32, 50, 72, and 98. 159 is about the biggest giveaway vocab question that you could really see. Level 1 has 1, and level 2 has 2, and shockingly level 3 has 3, and 4 has 4. 163 is about valence electrons, V-A-L-E-N-C-E. I won't mark it wrong if you put V-A-L-A-N-C-E, but that's not valence, that's a valence. And we're not talking about chemistry. What are we talking about? Valence. You know that word?
History.
No. Curtains.
What?
We're talking about curtains. Like the thing on your curtains.
Oh, really?
Look it up. It's called a valence. There's a valence is part of your curtain system. Someday some of you men will get married and learn that word. And some of you women learn that word before you're married, so you can teach it to your husband when you're shopping for curtains. Or maybe men that are into decorating now, that, hey, the world has changed. Maybe that's sexist. So maybe there are men that are really into decorating and teach their wives about valences now. I don't know. But that valence, I don't think I knew what that was until we had to put curtains in our house. Well, 164 is S, P, D, and F. S has 2, P has 6, D has 10, F has 14. You can use the numbers in 152 and 164 to like check each other, because the 2 appears in both lists. And then if you go 2 plus 6, that's a way to get to the 8. If you go 2 plus 6 plus 10, that's a way to check the 18. If you go 2 plus 6 plus 10 plus 14, that's a way you could check the 32. And then if you sense the pattern of every time it's 4 more and you'd like add 18, add 22, add 26, that's all completely valid. But those numbers, you can use them to check each other if you wish. And then we've got the crazy drawing. One S, 2S, 3S, 4S, 5, 6, 7. S's don't just have S's, there's S's and P's. So this level has S, P, and D. D. This has S, P, D, and F. 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 Am I still on camera that far?
You're not, but the number's on.
Okay, well, I don't need to be. As long as the answer's there, that's what matters. So we start here and we loop and we keep filling like this. And this is the order in which all of these different levels and sub-levels fill in. And I don't know if you had this conversation at the time, but level 1 has 1, level 2 has 2, 3 has 3, 4 has 4. That was the giveaway point from a minute ago. You kind of suspect that 5 should have 5, and that 6, it's not a 7, 6 should have 6, and 7 should have 7. And maybe it would. Why don't we have any way to know?
There's like nothing that can naturally do that.
Yeah, there's nothing that does that. How many elements did we have?
111.
We only need to add up to 111. So if you get to here, you're already like handled the 111 you needed to handle. But if we had to like get more than 111, you know, maybe there is I would suppose after F there's probably 5G, but you don't ever get to this part of the chart where like 5G matters. I think even up, I shouldn't have said there, even up to here, we can handle our 111. We don't need this. That's not perfect, but that's close. Question about what I got going there? Why is this imperfect? One other little detail.
Circle the
Circle who?
5D.
5D. Did we circle 6D also?
I had 60.
I'm pretty sure 6D is also circled. What does the circles mean? Anybody remember what that meant?
They like get more. We get them
Something about
first.
N.
Yeah, they're like line jumpers. Before the 4F gets any, 5D like cuts the line, takes 1, then 4F fills the rest of the way, and then 5D would get its second one after the F was filled, but the 5D cuts before the 4F to take the first one that's up for grabs after 6S. Likewise, the 6D. As soon as 7S is filled, 6D jumps the line to steal 1 out of turn, gets back in line, F gets filled, then the D continues. But those are circled, that's why those are circled. There's another way they did this in the book where it was like more straight line, something like this. If you like that version, hey, whatever, but I always like the squiggly one where it's stacked into the columns.